I'm going to show you a couple examples here that are going to involve a system of equations. And in algebra, one of the things you learn is how to solve a system of equations. But more importantly, in this video, what I want to show you in these two problems is that they can be solved without a ton of algebra, or without knowing like college algebra level skills. Okay, so like if you wanted to ask a 5th or 6th or 7th grade classroom this question, they'll probably be able to figure it out even though they don't know algebra. But all of these problems help to develop algebraic thought. So the first example is called the pigs and chickens problem. One morning, a farmer looks out in the barnyard and he sees a number of pigs and chickens. The farmer says to his daughter, "I count 15 heads and 48 feet. How many pigs and how many chickens are there?" So they told you how many heads and how many feet. So a couple assumptions that we have to make at the beginning of the problem. Every animal has one head, one and only one head. And if it's a pig, it's going to have 4 feet. And if it's a chicken, it's going to have 2 feet. We're going to assume there's no 3-legged pigs out there or anything, okay? So 4 legs or 4 feet on a pig, 4 feet or 2 feet on a chicken. Okay, those are the assumptions. So the first thing that you could do if you're going to have these kids work this problem out and they don't know algebra, they'd have to draw some sort of a picture. So the first thing is draw 15 heads. And I don't know if they're chickens or pigs, but I'm just going to draw a circle for the head. Okay, so I'm going to draw 15 of them. So 1, 2, 3, 4, 5. Okay, so there's my 15 heads that I've drawn. And what I know is every single one of these is either a chicken or a pig. So at a minimum, they would have 2 legs. So they all have to have at least 2 feet. So I'm going to put 2 feet on every single head. So currently, they're all chickens. If they all had just 2 feet, and there's 15 of them, that would be 30 feet that we have taken care of, right? If they were all chickens, we'd have 30 feet. But we don't have 30 feet, we have 48 feet, so that means we have some pigs. So I'm going to keep adding feet until I get to 48, but I don't want to have an animal with an odd number of legs. So if I'm going to add feet, I'm going to, through the magic of math, I suppose, I'm going to turn this chicken into a pig. So if I add 2 more feet, now it's a pig. So we had 30, 31, 32, 33, 34, 35, 36, 37, 38, 39, 40, 41, 42, 43, 44, 45, 46, 47, 48. At that point right there, I'm done because I've got my 48 feet. So we added more feet to get to 48. And now I can see this is a pig, a pig, a pig, a pig. All these that have 4 feet would be the pigs, and all the ones with 2 feet would be the chickens. You can solve it with a drawing, and you'd be amazed how much faster kids can solve this than adults, because we try to make things too hard. So how many pigs? 1, 2, 3, 4, 5, 6, 7, 8, 9 pigs and 6 chickens. That's how you can solve it with a picture. Now, if you just absolutely want to use algebra, and this is not anything I would test you on, like the solving equations, you would write out an equation for the number of heads. So you would say the number of pigs plus the number of chickens is 15. That's just the number, this is heads. Then you'd write an equation for the feet. 4 feet on every pig, 2 feet on every chicken equals 48. And you would be wanting to solve that system. And there's a lot of different ways you can solve it. That's not really part of the coursework, but one of the ways you can solve is you can add 2 equations together. So sometimes when you have multiple equations, by grouping 2 of them together, you can help to solve the third one. So we can group these 2 together. And there's a rule also that says I can multiply any equation that I want by any number, as long as I multiply everything by that same number. So I'm going to multiply this equation by -2. Just trust me, that's my magic strategic number I'm going to use. If I multiply this top row by -2, that's what I'll get. -2p minus 2c equals -30. And then I'm going to write the second equation underneath it. So all I did was kind of blow up this first equation. I multiplied it by -2. And the reason I did that is because what I want to do is add these equations together. And because of the strategic -2 that I picked, it's going to make these two terms cancel. And what you're going to get is 2 pigs is equal to 18, which can be very easily solved, that p is equal to 9. And if you know that there's 9 pigs and there's 15 animals, then the number of chickens has to be 6. So again, this is like where you would be headed, right, for algebra. But the big takeaway here is not, don't worry about the solving here. The big takeaway is that it can be done with a picture. And we can magically turn chickens into pigs. That's kind of cool too. All right, this next one, we're going to not really draw a picture as much. For this one, I am going to use some variables. And I'm going to kind of treat it like some other problems that we've seen in here. So it says, in a small town, 3 people deliver all of the newspapers. Abby delivers 3 times as many papers as Bob. Connie delivers 13 more papers than Abby. If the 3 people deliver a total of 496 papers, how many papers does each person deliver? So they gave us 3 pieces of information. I'm going to number them 1, 2, and 3, right? 3 people deliver all the newspapers, and we know their names. Now, I'm going to call Abby A, I'm going to call Bob B, and I'm going to call Connie C. So the first little clue that they gave us said Abby delivers 3 times as many as Bob. So Abby is 3 times Bob. So if Bob delivers 1 paper, Abby delivers 3. So 3 times. That's the first thing they told us. The second clue they gave us said Connie delivers 13 more than Abby. So Connie is Abby plus 13. Or whatever Abby delivers, add 13 to it, that's what Connie delivers. And then the third clue that they gave us said the 3 people deliver a total of 496. So that means A plus B plus C equals 496. So this is a system of 3 equations. But I'm going to show you that you can use the early equations to help you solve the later equations. They're going to kind of build on each other. So we're going to use information to try to not have an equation with 3 variables. I'm going to work with this equation because it involves everybody. But I would like to just have 1 variable and not have A, B, and C. So it tells me that A is 3 times B. So why don't I just take that and substitute it in for my A? I can say that A is 3B. I'm just changing it into Bob notation, right? Plus B, right, there's another B. So it kind of looks like maybe I want to stick with the variable B. Plus, what could I replace the C with? Well, the C could be replaced with A plus 13. If C is A plus 13, then C is A plus 13. You see what I did there? So I replaced Abby, I kept Bob the same, and I replaced Connie. Now I still don't have 1 variable. It'd be nice if they could be all A's or all B's. If I could just convert this A into a B. Oh, wait, A is 3B. So I'm going to change this A into a 3B. So I'm going to have 3B plus B plus another 3B plus 13 equals 496. So I just made the replacement again for A. So I used 1 and 2 to help me plug into 3. Okay, now how many B's do I have? 3 plus 1 plus 3 more, that's 7 B's plus 13 equals 496. And do you get rid of the 7 or the 13? You always want to handle addition and subtraction before you do any multiplication and division. So I'm going to subtract 13. Subtract 13. That's going to give me 7b equals, what's that going to be, 483? And since 7 is multiplied by the b, the way I get rid of it is I do the inverse. So I divide. And I'm going to come up with b is 69. It actually divides evenly if you use a calculator. So this is Bob. Remember, that's what the B stands for. So Bob delivered 69 papers. So what did Abby deliver? Well, she delivers 3 times as many as Bob. So Abby, if we take Bob times 3, we'll have Abby. That's 207. And then to get Connie, you take Abby and you add 13. So there's Abby, 207, add 13. You'll get 220. And how you can check your answer is you can add up the papers here. We got 207 plus 69 plus 220. 496. They said they all delivered 496. So that means we probably have it right. But notice that we took like 1 and combined it into 3 and 2 and combined it into 3. So sometimes you take, if you have like 3 or more equations or statements, you can combine 2 of them together to help you solve. So again, the idea was to try to narrow it down to just 1 variable instead of having 3. And we were able to do that by making some simple substitutions. So this 3b, we substituted for the a, and then we did it again there. And then the a plus 13 is what we substituted for the c. And we were able to whittle it down and solve for how many newspapers each person delivered.